Hello, happy Monday. Mrs. Hatfield here to take you through your daily math practice for week 12, day 1. I hope you had a good weekend. If you're in class with me, we are doing our bell work and we'll stop and pause occasionally. If you're at home, make sure you're watching the video and doing the same thing. Pause and solve. You got this, my friends. All right, number 1, we've got a soccer store can ship 7 soccer balls in each box. How many boxes are needed to ship 81 soccer balls? So let's kind of break this down. We've got a soccer store can ship 7 soccer balls in each box. Each is a key word there. All right. How many boxes are needed to ship 81 soccer balls? Well, we've talked before, a lot of times when I say, when you hear each, you're thinking either multiplication or division. If this is one box, it's going to take me forever to keep drawing 7, that's 14, 7. So instead of using that strategy, which, it would work, it's just going to take us a little while. We're going to say if we know that there are 81 soccer balls and there's 7 that fit in each box, we need to know the number of boxes. So we don't know that yet. All right. So we're going to take a look here. We're going to divide 81 divided by 7. I know 7 can fit into 81. Let's see here. About 11 times. 11 times 7 is 77. Got to regroup. 11 minus 7 is 4. So these 4 soccer balls left over are going to need a box as well. So you can't just say that you'll only need 11 boxes. You're going to need one more than 11 because of this remainder of 4 extra soccer balls. Number 2, Stella is using grid paper to make shapes. Her first shape has an area of 16 square units. Her second shape has an area of 24 square units. Her third shape has an area of 32 square units. If this pattern continues, what will be the area of her fourth shape? So let's break this down. We've got Stella using grid paper to make her shapes. Her first shape is an area of 16 square units, so that's our first one. Her second shape has an area of 24 square units, and her third shape has an area of 32 square units. We want to know what would be the fourth shape. Well, a couple things. You can already tell that this is an increasing pattern. It's increasing 16, 24, 32. So a couple different ways you could solve this. You can start kind of just guessing and checking by subtracting the numbers. So I'm going to do a little subtraction here. And that gets me 8. Oh, and I'm seeing a pattern here. I'm thinking in my multiplication facts. I see that this would also be 8. So it's increasing by 8. So if it's increasing by 8, what would this shape be? Or what would be the area of her fourth shape? We know the shape. What's the area of her fourth shape? Question number 3. Classify the lines. Remember, perpendicular lines intersect. Parallel lines do not intersect. Question number 5. Little rounding review. Getting a little bit more complicated. So round 563,047 to the nearest 100,000. So Mrs. Hatfield goes to place value. I go to 100,000. I look to the right and I ask my brain, hey brain, is 5 going to increase to 6 and this rounds to 600,000, or is it going to stay at 5 and round to 500,000? Same strategy for the second one. Round 849,066 to the nearest 100,000. Brain says 8. Look at the 4. Oh, that's the end of one of the class periods. And round it to either 800,000 or 900,000. Question 5, what is the measurement of the angle? Choose the best estimate. So it is not quite where, well, I don't know. Think of what you guys remember with this one. What's the best estimate on that one? Question 6. We are going to convert the fraction that is greater than 1 into a mixed number. So an example would be 4/4 or 7/4 is the same thing as 4/4 because 4/4 is 1 plus 3/4. And whatever I have left would turn into my mixed number. Let's take a look at what it looks like as a fraction pieces. So if I have 10/4, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. If I look here, this is one whole. Oops. And I have another whole. So it would be 2 and 2/4. And then another way to think about this, and sometimes you'll see this, they'll say take 10/4 and put it into a fraction statement or expression. If I know that 4/4 is 1, there's 4/4. There's my next 4/4, 8/4, plus, got 2 over here, 2/4. It could look like that as well. Question number 7, a little conversion of measurements. If we have 1 meter equivalent to 100 centimeters, how much is 2 meters? We have 3 meters. 3 meters is equivalent to how many centimeters? Question 8. Use partial quotients. Oops, that should be products. Okay, fixed it. Use the partial products model to help you find the product. Okay, so first step, 8 times 4. Second step, 8 times 6, or 8 times 6 tens. So make sure that's in the tens. You're thinking of 60. Okay, 5 tens times 4, 5 tens times 4, so you're thinking of 50 times 4. Just think 5 times 4 and add that 0. And then 5 tens times 6 tens. And multiply those across. Once you've gotten those, go ahead and add them up. So pause and solve. So here's how your work should look. If you add all of these up, that'll give you the answer to 64 times 58. Thanks for watching and have a marvelous Monday.